Okay, good morning, everyone. Today we'll take a look at graphs of rational functions. So we worked with rational operations, adding and subtracting, multiplying and dividing, solving for x with rational functions. We took a look yesterday at word problems involving rational equations. Today we'll actually take a look at what a rational function looks like. The rational function we're going to begin with, the parent function is f of x or y is equal to 1 over x. If I go out to decimals, I graphed the function. As you can see here, y equals 1 over x. And this graph has the shape of what's called a hyperbola. A hyperbola. And I want you to notice this graph we will say is discontinuous. In other words, this graph has breaks. If you look at the red lines here, you see that they kind of break apart. Okay, so that's what the graph of y equals 1 over x looks like. Let's explore this graph numerically. Here I have a table. Okay, so x and then y 1 over x, or x1 and 1 over x1. Okay, so when x is 0, dividing by 0, 1 divided by 0 is undefined. I want you to notice here the graph, this red graph here, breaks up and x is equal to 0. And x is equal to 0. We say the graph is discontinuous at x is equal to 0. But then as we get more and more negative, like at negative 1, 1 divided by negative 1 is negative 1, 1 divided by negative 2 is negative 1/2, and then when we get to x is negative 10, 1 divided by negative 10 is negative 0.1. So as x gets more and more negative, I want you to notice that graph, that red line there, it gets closer and closer to the value y is equal to 0. Okay, now that graph will never cross the x-axis, but that graph, as x gets more and more negative, that graph gets closer and closer to 0. And if I took a look at the right side of the graph, here again at x is equal to 0, the graph is undefined, but when x is 1, 1 divided by 1 is 1, 1 divided by 2 is 1/2, and 1 divided by 3 is 1/3, all the way till 10, 1 divided by 10 is 0.1. So as x gets more and more positive, the graph, again, gets closer and closer to the line y is equal to 0. Y is equal to 0. So the graph breaks up in two places, right? It breaks up when x is equal to 0 because we can't divide by 0, and then it never crosses the x-axis. Okay, so to recall, when we were looking at exponential functions and logarithmic functions, we talked about something called asymptotes. And so we would say this graph, y is equal to 1 over x, has a vertical asymptote, a line that goes up and down at x is equal to 0, because the graph gets closer and closer to the line x is equal to 0. But it never gets to x is equal to 0 because we can't divide by 0. So we have a vertical asymptote that goes up and down at x is equal to 0, and then we have a horizontal asymptote at y is equal to 0. Remember, the asymptote is a imaginary place in a coordinate plane that a graph approaches but never crosses. It gets closer and closer to some value. So if I go here, so for this graph here, let's label some things. Our objective today is to identify transformations of the parent function f of x is equal to 1 over x, identify asymptotes, and identify domain and range. So for the parent function here, I had, so this was y, or f of x is equal to 1 over x, or y is equal to 1 over x. Okay, so again, I had a horizontal asymptote. Okay, that graph gets closer and closer to the line y is equal to 0. So my horizontal asymptote, and I'll just label that HA is y equals 0. So the graph gets closer and closer to the line y is equal to 0. And then I have a vertical asymptote here. A vertical asymptote. Remember on your quiz I told you, on your test in chapter, what was that, 7, I said you always had to indicate what letter for the asymptotes, x or y. And so here this has a vertical asymptote. I'll call it VA at x is equal to 0. That's where the graph breaks up. Okay, so the function y is equal to 1 over x has a horizontal asymptote at y is equal to 0 and a vertical asymptote at x is equal to 0. My domain for this function, well, that would be x. I can't have x is equal to 0, so it would be x not equal to 0. I can have any other number, but I can't have 0 because you can't divide by 0. And then my range, I get all values for y except y is equal to 0. Okay, so y is going to positive infinity, and then it goes closer and closer to 0. Here it gets closer and closer to 0, and then it goes to negative infinity. Okay, so my range is all values except y not equal to 0. Y not equal to 0. So now I want you to notice that my horizontal asymptotes and vertical asymptotes are just about the domain and range. Okay, so for the domain x not equal to 0, that's my vertical asymptote, x is equal to 0. For my range, y not equal to 0, that's my horizontal asymptote, y equals 0. So that's the basic rational function. Now here, so let's make some transformations here. Let's see here what happens if I make transformations. So I'm going to clear out the table. What happens if I have now one? So I'm going to change this graph here. What happens if I now have this function here? So 1 divided by, let's say here, x minus 4. Okay. I want you to notice here when I have the graph y is equal to 1 over x minus 4, I shifted my vertical asymptote over 4 units. Okay, and that makes sense because, again, I can't divide by 0, so if x is equal to 4, 4 minus 4 is 0, that's where that graph is going to break up. I have a vertical asymptote at x is equal to 4. I shifted the vertical asymptote over 4 units. My horizontal asymptote remains the same, though. The horizontal asymptote remains the same. Y is equal to 0. So let's take a look at this one here. So with this one here, okay, so this was a transformation, and I shifted the graph over 4 units, so y equals, that was 1 over x minus 4. Okay, I shifted the graph. Again, my domain then will be all x's except x not equal to 4. Okay. That will be my vertical asymptote. My vertical asymptote will be x is equal to 4. Again, so as you can see there, I have a vertical asymptote, but x is equal to 4. And then the range hasn't changed. It's y not equal to 0 because I still have a horizontal asymptote at y equals 0. So my horizontal asymptote is still y equals 0. Okay. There. So y is equal to, so I shifted the graph over 4 units to the right. I shifted the vertical asymptote over 4. The horizontal asymptote y is equal to 0 remains the same. All right, so now let me go back out to decimals here. So now let's see here. Okay, so I'm going to just change the graph, but rather than shifting the vertical asymptote, I'm going to shift the horizontal asymptote here. So I'll change the graph to, I'll keep 1 divided by x, but then I'll subtract 5. Oops. All right, so I subtract 5. I want you to notice my vertical asymptote now is still at x is equal to 0, but I shifted my horizontal asymptote down 5 units. I shifted this graph down 5 units here. Okay, so let me make a copy of this here, and then we'll talk about it. will describe the asymptotes in the domain and the range. Okay, so this was a graph. So this was a graph y is equal to 1 over x minus 5. I shifted my horizontal asymptote down 5 units. The domain for this is x not equal to 0. I can't divide by 0, so x not equal to 0. But now my range is, I have a horizontal asymptote. I have a horizontal asymptote here at y is equal to negative 5. So my range is y not equal to negative 5. My vertical asymptote, though, is still at x is equal to 0. In my horizontal asymptote, now, though, is y equals negative 5. I shifted the horizontal asymptote down 5 units. And then 2 more of these, and we'll kind of combine transformations, and then that will be it. I just want you to understand the basic transformations of the parent function 1 over x. You should be able to describe the asymptotes as well as the domain and range. So let's look at, all right, so I'm going to change this here, and now let's see here. I'm going to shift this graph to the left, so I'll go x plus 2. I'm going to shift the vertical asymptote over 2, and then I'll shift the horizontal asymptote up 3. Okay, so let's take a look at this here then. All right. So I want you to notice I shifted the vertical asymptote over 2 units to the left from the parent function 1 over x. I can't have negative 2. Negative 2 plus 2 gives me 0. So x can't equal negative 2. And then you see I shifted my horizontal asymptote up 3 units. So let me make a copy of this, and we'll describe the domain and range, as well as the asymptotes. So with this one, this graph here, the function was, and looking, you should be able to take a look at a graph and actually write a function for it, at least a hyperbola. So my function was y is equal to 1 over x plus 2. X plus 2. The domain, x not equal to negative 2. I can't have negative 2. Okay. And then I have a horizontal asymptote. Oops, and that was at, so I shifted the graph up 3 units, wasn't it? So I'm pretty sure plus 3. I shifted the graph up 3 units because I can see that I have a horizontal asymptote at x, or y is equal to 3. I shifted the graph up 3 units. So my range then is going to be y not equal to 3. Okay. I have a horizontal asymptote there. So my horizontal asymptote will be y equals 3, and then my vertical asymptote would be x equals negative 2. X equals negative 2. So I can see that in the graph. Again, here's my vertical asymptote right there. X is equal to negative 2. And then my, okay. So 1 over x plus 2, I shifted the graph to right left 2, and then I shifted the graph up 3 units. And then the last one here, and then we'll be done for the day. So go back out to here, and we'll make one more transformation, and that will be it. So let's see here. I'll shift the graph to the right 1, so x minus 1. I'm going to shift my asymptote 1 unit to the right, and then I'll shift it 2 units, the horizontal asymptote 2 units down. So 1 over x minus 1. Shift the vertical asymptote over 1, and then the horizontal asymptote down 2. And then I'll graph this, and then we'll talk about it. So as you can see, they're not, these working with these graphs are not so bad, and excuse my dog. Okay, apparently he sees another cat. Max, be quiet. Okay, so let's see here. So this was, and again, you should be able to take a look at a graph and see what's going on here. So y equals 1 over, I shifted my vertical asymptote over 1 unit. So that's going to be x minus 1, because I can't have 0 on the denominator. 1 minus 1 gives me 0. And then I see I have my horizontal asymptote at y is equal to -2. So I shifted the graph down 2 units. Okay. So y is equal to 1 over x minus 1 minus 2. And so again, the domain here would be x not equal to 1. And my vertical asymptote then would be x equals 1. And then the range would be y not equal to -2. And then I would have a horizontal asymptote and y equals -2. So you should be able to describe the transformations, the domain and the range, the horizontal and vertical asymptote of the transformations of the rational function, as I have done here. And you should be able to sketch it as well. So on homework, I'll give you something like this here. So let's say here, if I had y is equal to, I'll shift the graph over 3 units to the right, for example. So this will be x plus 3, and then maybe I'll shift it up 2 units. And so when I say graph it or just sketch it, you should be able to sketch, and this is what I usually require. Okay, so you should be able to sketch in your asymptotes for sure. So I'll have a vertical asymptote at x is equal to -3, because -3 plus 3 would give me 0. And so I will sketch in just my vertical asymptote like this here. So this would be x equals -3. I have a vertical asymptote there. I shifted the graph over 3 units. And then I shifted it up 2 units. And then I'll have a horizontal asymptote, and you should sketch in your horizontal asymptote like this here. Yeah, so that horizontal asymptote would be y equals 2. And then you can just sketch in your graph, okay? Just to sketch it in. So my graph would look something like this, the basic graph. It would look something like this here. It would hug the asymptotes, right? Like that. And then like that. All right. So when I ask you to graph or sketch it, that's what I'm looking for. I'm looking for that you've identified the asymptotes, and then you've just sketched in what the graph will look like. And you can certainly look on Desmos to help you out there. And of course, then you have to give me the domain and the range. So again, the domain would be x not equal to -3. My vertical asymptote would be x equals -3. And then the range would be y not equal to 2. And then my horizontal asymptote would be y equals 2. So that's what I'm expecting you to do on your homework. Sketch the graph, give me the domain and the range and the vertical and horizontal asymptotes.